Hey guys, this is lesson 6.1 for algebra. It is rate of change and slope. Hopefully most of this is a review. Rate of change, it allows you to see the relationship between two quantities that are changing. If one quantity depends on the other, then the following is true. So it's the change in the dependent variable over the change in the independent variable. So if you remember, our independent variables are our x variables, and our dependent variables are our y variables. So if you remember, and we'll see later on, it's the change in the y's divided by the change in the x's. So, finding the rate of change using a table. For the data at the left, is the rate of change for each pair of consecutive days the same? What does the rate of change represent? So when I see a table, I look here and I notice, okay, the days are all going up by 1. And here it's going up by $15 each time. So that means the rate of change is 15 divided by 1. The change in the y divided by the change in the x. So it's 15 divided by 1. So find the rate of change using days 5 and 2. So if I just looked at 5 and 2, like if I didn't have these other days, they weren't on my table, I would say, okay, it goes from 75 to 120, so that's a rate of change of $45, and from 2 to 3 is a change in 3 days. So you would do 45 divided by 3, which still gives you 15 per day. Does finding the rate of change for just one pair of days mean that the rate of change is the same for all the data? So yes, if it is a linear function, they're all going to be the same. It's going to go up by the same amount each time. So finding the rate of change using a graph. So the graph here shows the altitude of an airplane as it comes in for a landing. Find the rate of change. Explain what this rate of change means. So what they do is the vertical change divided by the horizontal change. So vertical change meaning, if you see here, what they did is they used 2 points. They used this point right here and this point here. So this is 1,000 and this is height 0 or altitude, feet above. So they subtracted those two and then they said, well, it went from 60 seconds to 180 seconds, and then they subtracted those and they found that it was 1,000 over negative 120, so that was a negative 8 1/3. So find the rate of change in this graph. So try this problem in your notebook. Okay, so I'm going to use a couple points here. You could pick any two that you want. So if you pick 2 points, you have 0, 0, and 2, 100. So I'm going to subtract my y's, 100 minus 0, and then I'm going to subtract my x's, 2 minus 0. So then I get 100 over 2, which is 50. So now, the rate of change is 50, but then you have to see, okay, it's miles per time. So it's 100 miles in 2 hours, so that means it's 50 miles per hour. Okay, the slope of a line is its rate of change. So slope, write this down, equals rise over run. This should be a review. Rise over run, if you remember this from last year, you would take 2 points on a linear line. Remember the word linear from last year, from pre-algebra. And remember I made you circle the word line, because anytime you see the word linear, it really just means line. So here's a linear line, linear graph, and you're going to find the slope. So slope is rise over run, right here, rise over run. So rise is 2, and run is 1, 2, 3, 4, 5. Remember, you're counting the boxes. So if you're on a graph, you would count each unit as a 1. So the slope of this would be 2/5. Now, the slope here as I go from one point to the next. If I do rise first, well, I'm not going up. I'm going down 3. So that's a -3 over 1, 2, 3, 4, 5. So it'd be -3 over 5 for the slope. So try these two. Okay, I'm going to go here. I'm going to do my rise. 1, 2, 3. So my rise is 3. 1, 2, 3, 4, 5. And my run is 5. So my slope is 3/5. Here, I'm going to start here. Now my rise, I'm going down, so that's -1. And my run is 1, 2, 3, 4, 5, 6. So this would be a -1/6 slope. All right, so remember this from last year. Hopefully it was drilled into your head. y2 minus y1 over x2 minus x1. So try these two problems. Okay, so I am going to start by labeling y1, x1, x2, y2. So y2 is 7 minus 5 divided by 4 minus 2. 7 minus 5 is 2. 4 minus 2 is 2. So that has a slope of 1. Here I have x1, y1, x2, y2. So this would be -2 minus 4 over 3 minus -1. So this is -6, and this is 3 plus 1 over 4. So that would be -3 over 2, or -1.5. All right, so find the slope of each of these two lines. So now, you can do this a couple different ways. You could find points. So if I found just 2 random points on my line, this would be 2, -3. And this would be -2, -3. And then I could find my slope this way. So then y2 is -3 minus -3. And x2 is 2 minus -2. So -3 plus 3 is 0, and 2 plus 2 is 4. So now, if I have 0 over 4, my slope is just 0. It has no slope because it's a straight line. It's like walking on a straight, completely flat surface that has no slope. You're not walking uphill, you're not walking downhill, you're just walking straight. So it's a slope of 0. Now, this one's a little bit different. So if I pick 2 points, so now this would be -2, 1, and this is -2, -2. So if I label my points, x1, y1, x2, y2, y1 is, or y2 minus y1 over x2 minus x1. Whoops. Not comma. Oh gosh. So -2 minus 1 is -3, and -2 plus 2 is 0. Now, if the 0 is in the denominator, your slope is known as undefined. It's not possible. You can't have any slope. So this is a straight up and down, a straight vertical line. It has absolutely no slope. Where this has a slope, this line over here for A has a slope of 0 because it's flat and you could actually walk on it. Here, you could not. It's completely straight up and down, so it has no slope. It's undefined, is what they say. All right, that's it for your notes.